This is your statistics exam review for the spring 2020. All right, here we go. Which of the following is not true of statistics? All right. A, statistics involves collecting and summarizing data. That sounds pretty good. Statistics is used to draw conclusions using data. That sounds pretty good. Statistics can be used to organize and analyze information. That sounds pretty good. Statistics is used to answer questions with 100% certainty. Aha. That one right there. That ain't it. D. D is the answer here of which of the following is not true of statistics. A, B, and C are all true. You don't 100% certain say anything in stats. All right. Let's see. Let's go to the next one. Select a random sample of 5 state capitals from the list below. So they're labeled 1, 2, 3, 4, blah, 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 all the way to 50, right? Then you have your table of random numbers down here, right? We have the table of random numbers down here. So we want to go through there, and we start at 46. So if we look at 46 right here, we look over here. Where's 46? Springfield, Illinois. That's our first one, okay? That's our first one, Springfield, Illinois. All right, so we have Springfield, Illinois. All right, and then I probably should have written that higher, but anyway, 53. If we look at 53, it stops at 50, so 53 is not on there, so we don't worry about that one. We just say, okay, let's skip 53. All right, and then 3. 3 is this one, Atlanta, Georgia, right? So Atlanta, ATL is our next one. 39 is right here, Providence, Rhode Island. All right, so Providence, Rhode Island. Okay, and you may can look at it and go, oh, well, the answer's got to be D, but let's keep going just to get a feel for this. Then we go 45, and 45 is Santa Fe, New Mexico. Okay, Santa Fe, New Mexico. All right, and I didn't. Whoa. Let's undo that. We'll just leave that circle there for now, because apparently I just erased the whole problem. We won't do that. All right, and then the next one is 81, and 81 is not on there. 78 is not on there. 99 is not on there, and 14. 14 is Columbus, Ohio. So guess what? That is Springfield, Atlanta, Providence, Santa Fe, and Columbus. D for number 2. D. All right, so we go through, and 46 we picked it. 53 wasn't there, we couldn't pick it. 3 we picked it. 39 we picked it. 45 we picked it. And then we said, oh wait, 81's not there. 78's not there. 99's not there. And then we picked 14. All right. So let's look at the next one. Identify the type of sampling used. Every 5th adult entering an airport is checked for extra security screening. What is being used here? Well, if you do every kth one or every certain one, then that is systematic, right? That is systematic, which in this case is B. So let's get a different color today. Let's see. Let's pick a blue hue here. How about blue? The heights of 10 female students in inches in a college math class are listed below. Find the mean. Well, how do I find the mean? Yep, I say 65 plus 66 plus 67 plus 66 plus 67 plus 70 plus 67 plus 70 plus 71 plus 68, and I add all those together, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, just to make sure I have 10 of them, because that's what I said I had, right? So if we add them all together, we get 677 divided by 10, which should be 67.7 inches, and that is answer choice C. That's an awful C. We'll fix that. Answer choice is not a much better C, but anyway, answer choice C. All right, so let's keep going here. Let's see. We have the number of students in a physics class for the last 10 semesters. Find the median. So to find the median, we need to put these things in order from smallest to largest, right? And take the middle number, or if it's an even number, the middle two numbers, and take the mean of those average. So is anything less than 65 here? No. So the first number is 65, and we took care of that one. And then we have what? 66. We have 1, 2 66s, so 66 and 66. And then we have 67, 67, 67. There's 3 of those, 67, 67, 67. And then we have a 68. And then we have 2 70s, right? And then a 71. So that should be 10 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So we say 1, 2, 3, 4, 5, 6. It's the average of those two, which happens to be exactly 67, which is C. I know this poor presentation here because I wrote all over everything. But anyway, if we go between the 5th and the 6th numbers and take the average of those two, they're both 67. So the average of 67 and 67 is still 67. And if you'll notice, if you look back at number 4, I believe that's the same list of numbers on number 4 and number 5, and then on number 6, it's the same list of numbers. The commuting time, except it's heights of female students in a math class, it's the number of students in a physics class, and it's commuting times of 10 employees in minutes. Find the mode. So here, if we look through here, the mode's going to be the one that occurs the most. 65 occurs once, 66 twice, 67 3 times, 70 twice, so 67 is the mode there. So then for number 6, it should be B. All right, 67 is the mode. 67 minutes, that's the one that occurs the most. All right, so let's go ahead and get us another color here. Let's come over here and find us a different color. Well, I love my computer. It's slow. I have to hit it and wait a minute because otherwise I'll keep going back and forth like I did. Let's pick an orange here. All right, so compute the range of the set of data. The range is what? It's the largest value minus the smallest value. Here, the 12 is the biggest, 8's the smallest, so the range is 4, and that looks like B. B for number 7, the range. All right, largest value minus the smallest value. So then the amount of television viewed by today's youth is of primary concern to PALT, Parents Against Watching Television. 300 parents of elementary school age children were asked to estimate the number of hours per week their child watched television. The mean and standard deviation were 14 and 3 respectively. So PALT constructed a stem and leaf diagram, blah, blah, blah. Give the interval around the mean where you believe approximately 95% of the television viewing times fell in the distribution. So if you recall, our empirical rule says when we have our bell curve here, right, then within 1 standard deviation, right, this is 68%. And then if we go 1 more standard deviation out and go 2 standard deviations, we're at 95%. So 14 was our mean, and then our standard deviation was 3. Means we add to 17 and 20. That's not 20. That's 30. Let's try 20. Okay. And then if we subtract 3, we get 11 and 8. Right. We keep subtracting 3. The reason I subtracted 3 twice and added 3 twice was because of the 95%. If it had said 68%, I would have only added 3 once and subtracted 3 once. If it would have said 99.7%, I would have added 3 times and subtracted 3 times. So it's that 95% tells me to do it twice. It's 2 standard deviations away from the mean. So this is between what? 8 and 20 hours, which is B. So then number 8 should be B. B, between 8 and 20, which is 2 standard deviations on either side of the mean. Number 9, in terms of probability, a blank is any process with uncertain results that can be repeated. Is that an experiment, an event, a sample space, or an outcome? Well, an experiment. That's an experiment. It's any process with uncertain results. You're experimenting, right? Just think about the word. If you just say, I'm experimenting with this, well, that's because you don't know what's going to happen. You're just trying some stuff out to see what's going to happen. So that's what this is exactly, is an experiment. So let's get another color now. Let's find the green. Let's find the green. All right. Here we go. A die is rolled. The set of equally likely outcomes is 1, 2, 3, 4, 5, 6. This is fair die, 6-sided die. Find the probability of you getting a 5. So a 5 is 1 out of how many outcomes? 6. So which one is 1/6? That should be D. So then for number 10, the probability there should be D. Getting A5, that's one outcome that works out of 6 possible outcomes, so 1 out of 6 is your probability. Number 11, you have a spinner. It's divided into 5 equal parts, 1, 2, 3, 4, 5. They're even numbered. It said if the pointer lands on a borderline, spin again. Okay, so find the probability that the arrow will land on an odd number. So how many of those numbers are odd? Well, you have 1, 3, and 5. You got 3 numbers that are odd. So that means you have 3 ways it can work. Out of how many different numbers do you have on the spinner? 5. So 3 out of 5 chance it's odd, which is D. So then 10 and 11 both are D. 11 is also D. All right, let's go on to number 12. The events A and B are mutually exclusive, okay? If the probability of A is 0.2 and the probability of B is 0.3, what is P of A or B? Remember, or in probability means add, and if they're mutually exclusive, you don't have to worry about anything, just add them together. So this is literally 0.2 plus 0.3. It's the probability of A plus the probability of B. That's exactly what this one is. Whenever it's mutually exclusive, that's the key there. If it wasn't mutually exclusive, you would have probability of A plus the probability of B minus the probability of A and B. All right, and that's a general addition rule that you could look back up in one of your sections there. But here, I tried to make this a little simpler and say, hey, it's mutually exclusive. You don't have to worry about that minus and part. You just add them together. So this should be 0.5, okay? 0.5 are exactly 1/2, which is B. So let's look, 12 should be B, all right? So 13, suppose that events E and F are independent, and again, if you multiply, if you have an and with given or anything else, so you just multiply the two together. So this is going to be P of E times P of F, which is 0.9 times 0.6, which is 0.54, I believe. That's going to be A. So 13 is A. All right. Again, the independent part there says, hey, just multiply those two together because one does not depend on the other. You don't have to say E given F or anything like that because it doesn't matter if it's a given, it doesn't affect it. It doesn't matter. All right, so a bag contains 10 white, 12 blue, 13 red, 7 yellow, and 8 green wooden balls. A ball is selected from the bag. That's important that it's replaced. So first of all, how many balls have we start with? We got 10 plus 12. This is 22. And then we got 13 plus 7 is 20. That gives me 42. And then 42 and 8 is 50. So there's 50 total balls here in this bag. Okay? So there's 50 balls here. Okay? All right? So the second ball. Randomly take another ball out, it's also red. What's that probability? Well, how many red balls did you have? 13 out of 50. And then if you replace it, you still have 13 out of 50. You have 13 out of 50 times 13 out of 50. So 13 times, I can't type in my calculator, 13 times 13 is 169. Over 50 times 50 is 2,500, and then that's going to be 169 divided by 2,500 is 0.0676, which is C. So 14 is C. But the key there was replacement. If you didn't replace the first one, if you pulled a red ball out and then said, okay, I'm going to keep this over here to the side, and then I'm going to pull another one out and it's red, then you would have 13 over 50, and there would only be 12 and then 49 total balls left, so it'll be 12 out of 49 if you didn't replace it. But here you replaced it, so each time you had a 13 out of 50 chance of drawing a red ball. If it had been yellow, it would have been 7 out of 50, and another yellow one, another 7 out of 50. If it had been white, it had been 10 out of 50, and another 10 out of 50. So that's how that works there. All right, so let's go on to number 15. True or false? 0 factorial equals 1 factorial. That is true because both of them are defined to be what? That's right, 1. Both of them are defined to be 1. So that is true. If you recall, 0 factorial equals 1 and 1 factorial equals 1. Those are both defined in the textbook to be 1. All right, so find the value of the permutation 10p7. Look, put it in your calculator. I mean, you just put it in. But if you don't know how to do that, you need to remember the formula then. So NPR equals n factorial over n minus r factorial. So this one's going to be 10 factorial over 10 minus 7 factorial, which is 10 factorial over 3 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial. That's 3 factorial over 3 factorial. That's 3 factorial. And those divide out. So I'm left with 10 times 9 times 8 times 7 times 6 times 5 times 4, which is a bunch. So 10 times 9 times 8 times 7 times 6 times 5 times 4 is 604,800, which is B. All right. So I went through the formula. You can't hardly read my writing because, again, I don't have something that works on my computer screen. It's touch screen, but I'm having to use my fingertip, and it's not good. So I apologize for how terrible this writing is, but hopefully this is helping. But again, you just punch out in your calculator a nice, good answer there. So let's go ahead and pick blue again because I like blue. That's my favorite. All right. 10C3. So for combination for NCR, it's n factorial over r factorial n minus r factorial. Okay? So it's got an added factorial in the denominator. So this is going to be 10 factorial over 3 factorial and 10 minus 3 factorial. So that's going to be 10 times 9 times 8 times 7 factorial over 3 times 2 times 1 times 7 factorial, because that's 7 factorial right here, okay? And so what happens is these divide out, and then I can say, okay, 9 over 3 becomes a 3, and 8 over 2 becomes a 4, so I got 10 times 3 times 4, which is 120. And so then 17 is D, it's 120, okay? So again, you got your calculator, you go to your stats menu, and your calculate menu, and you go find it, and you say, okay, you type in 10 NCR3 equals enter whatever, and boom, it spits out 120, and you're done. Same thing, 10P7, 10 NPR7 equals, and it's going to spit out 604,800, and you will be done with that one as well. All right, so number 18, the graph of the normal curve is given. So use the graph to identify the value of mu and sigma. So remember, mu is where? Mu is right here. So if that's mu is this number in the middle, which is 849. That's terrible. And then how do I get sigma? Sigma is the difference between these two, or the difference between these two, or the difference between these two. You just pick any two consecutive. So if I do 881 minus 849, then that's going to be 32. So then sigma is 32, and so then 18 is D. Mu is, just mark through half of the next problem. All right, so mu is 849, sigma is 32, but you find the difference there. You take the middle number for mu, and you take the difference between that and either line on either side of it, or any two of the numbers for that matter. They should all be 32 apart. All right, so the z-score, find the z-score for the value 59 when the mean is 64 and the standard deviation is 5. So if you remember, and let's see, I'm going to go ahead and let's go back to orange here for a second. Let's go back to orange. All right, so if you remember, z equals x minus mu over sigma. So 59's x, the mu is 64, and sigma is 5. So the z-score here is going to be 59 minus 64 over 5, which is negative 5 over, I'm not sure what that's supposed to be, 5, which is -1. So my z-score is -1, and we typically do it to 2 decimal places, which is why B looks like that and says -1.00. So B is our final answer there. So let's go pick green again, just because. Let's pick a nice dark green this time. All right. The null and alternative hypotheses are given. Determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed, and the parameter that is being tested. So here, H naught, the null hypothesis, is mu equals 8.3. Remember, it's the one of no change or status quo. And the alternative hypothesis is H sub 1, and it is mu is not equal to 8.3. So first off, we are dealing with mu, okay? So that means we can't have this one and we can't have this one because they're both X bar. So we need to chunk those in the garbage, okay? So we also look at this not equal means it's on both sides of mu. That means it's to the right and to the left. There's a tail to the right, a tail to the left. It is two-tailed. Two-tailed, and mu is our parameter we're being tested here. So that is two-tailed. It is mu, and that is D for number 20, and that concludes our final exam review for the spring of 2020. Good luck. Be sure you go do your homework, the remaining of your My Math Lab assignments that you haven't done, and get how many ever done I put in your thing. I think you'll have to get 18 done or something. So just make sure you have those done. All right.